Here are a few more questions that are combination word problems. We could also call them multi-step word problems. These ones in particular have got two steps. So I could be even more specific and call these two-step word problems. Either way, there is more than one step, and that changes the strategy that we use. Up till now, the problems we've solved have been problems involving one operation, one step. What we're seeing now is two steps, two operations. So the difference we're going to notice is going to be here in step number three. Step number three, and this is the video about, a second video about the two-sentence strategy for solving word problems. Now, in the previous video, we talked about the two-sentence strategy. We saw a couple of examples. I mentioned then, too, that if you read a combination, or I could also say multi-step, or in this case, two-step word problem, if you read it and it becomes obvious to you from your reading the steps that you need to do to solve it without using a strategy like this, go ahead and solve it. Strategies are meant to help us when the other tools that we have aren't enough to do the job. My advice, though, is to take the time to practice strategies with simple problems that you might even be able to solve without the strategy, so that you've got easy questions to practice the strategy on. In real life, though, when you're sitting down at the kitchen table, or when you're in the workplace, or when you're running your own business, and you've got a combination problem to solve, but you can see how to solve it without a strategy, go ahead and solve it without a strategy. Use the steps that come to mind. All right, so this problem. Martha borrowed $4,600 to buy a new car. She will have to pay $728 in interest. She plans to pay back the loan plus the interest in 24 equal monthly payments. How much will her monthly payments be? We've been talking a lot with word problems how in order for me to have any chance of solving the thing, I really need to have a very good idea of what's going on in the story. So I'm going to read it again. So Mary's buying a new car here. She's borrowing $4,600 from the bank. From experience, I know when you borrow money, you end up paying interest. So this says she will have to pay that much interest on this money that she's borrowed. She plans to pay back the loan plus, really important word, pay back the loan and the interest in 24 equal monthly payments. Monthly payments that are equal 24 of those. How much will her monthly payments be? All right, let's follow the 5 steps. All along, my suggestion has been to follow these 5 steps for solving word problems, and the best way to do that is to use a highlighter to help you to think through the first bunch of steps that happen right in the question. Using a highlighter will cause your mind to slow down enough that you might notice details that would slip by if you just skimmed through the thing in a hurry to solve it. So here we go. What does the question ask us to find? How much will her monthly payments be? And again, I'm noting that our solution should be amount of money that will be the monthly payment to pay off the interest and the loan, the interest and the amount that you borrowed. That's what we're being asked to find. Step 2 is to say what's the necessary information. So I know that $4,600 is how much she borrowed. That's one piece of information I'll need to know, because that needs to be paid back. Here's the second thing I need to know. That when she borrowed that much money, she ended up having to pay the bank not just that money back, but also some interest as well. So that's the second thing I need to know. She needs to pay both of those things back. And I also need to know she's not paying it in one great big check. She's going to take 24 equal monthly payments to pay it off. Pay it off over 24 months, which 12 months in a year, that's 2 years that she's going to take to pay this thing off. We have just done step 2. We've looked at our necessary information. We're on to step 3. And step 3 In single step problems is where we decide, so what operation am I going to use? The video on the 4 arithmetic operations is really helpful in training our minds to recognize, oh, we're putting things together. That's got to be adding or multiplying. And multiplying under special situations can be a fast way of putting together many things that are the same. But now that we're doing a combination or a two-step word problem, there's more than one operation going on. We're going to use the 2-sentence strategy to help us figure out the 2 steps and the 2 operations involved. So I'm going to start with the blue highlighter. Write the solution sentence for the problem. We did this in the last video, but we started this by saying, well, then I need to know what is the solution I'm looking for. And that goes right back to the first question. I'm looking for how much will her monthly payments be. So my solution sentence, remember the word solution, the word answer means the same thing. This is my answer sentence. How am I going to get my answer? How am I going to get my solution? What's the step that I'm going to take to do that? So the solution is the monthly payment amount. So I'm going to say, okay, well, then the amount for the monthly payment, how am I going to find that out? This is the solution I'm looking for. My solution sentence tells me how I'm going to get that. Well, the amount of the monthly payment has got to be the total that she needs to pay back. The total that she needs to pay back. And that needs to be split up by the number of payments that she's making. Notice when I said split up, I wrote down divide, because I know that the operation of division is the operation in math that does splitting into equal parts. There's the clue here, equal monthly payments. There's another clue that I'm splitting something into equal bits. Division is the operation I want. So there's my solution sentence. If I look back up here in the fine print, it says, write a solution sentence for the problem. Fill in only the necessary information that belongs in the solution sentence. So this is what I'm looking for. So I know I don't have that. That's the solution. That's why I'm doing this problem, to find out the amount of monthly payments. But to do that, I need to have the total that she needs to pay back and the number of payments. Well, do I have the number of payments? Yes, I do. It's 24. Okay, so I'm going to copy that in. That number is 25. That number is 24. So whatever I'm going to do, I'm going to end up dividing by 24. The other thing that I need to know to get my solution figured out is the total amount that she needs to pay back. Now, when I look at the total amount she needs to pay back, that is not a number that they gave me in the question. So this is another example of, this is something I don't know yet. I can know it. I have enough information to find it out, but I don't know it yet. So this right here is what we're calling our missing information. So we're going to take our missing information and write our missing info sentence. So the missing info sentence is going to start with what I'm missing, the total she needs to pay back, and I'm going to write a sentence to help me to find that. Well, that's got to be the amount of the loan plus the interest that she needs to pay back. And now I can say, oh, well, look at that. I know what the loan is, $4,600. I know what the interest is, $728. I know what this is and this is, so I can find this. Once I find that missing thing, it's not missing anymore, obviously, whoop, then I'm going to plop it in here. I already know this, and now I can find that. So wow, lots of clocks going on in the house here. It's 12 o'clock. So the amount for the loan, $4,600, and the amount for the interest, $728. Those are both dollar amounts. When I add those together, 8,235, using my mental math skills there, $5,328 is the total amount that she needs to pay back. So this piece of missing information is no longer missing. I used my missing info sentence to figure it out. Now I'm going to take this and put it right up here where it belongs. 5328 is the total she needs to pay back. And now I know that in order to figure out the amount of the monthly payment, each monthly payment, I need to take the total she needs to pay back, 5,328, and divide that into 24 equal monthly payments, and I'll get my answer. I'll stop there. You could keep going. We haven't solved it yet. And then step 5 would be the step where I'd say, well, does that make sense? Our goal here is just to practice the two-sentence strategy for word problems. All right. Here's a second word problem that we can work on using the two-sentence strategy. Let's go and walk through the 5 steps for solving word problems again. Find what the question is asking us to find. That's step number 1, right up here. So for the convention, each of the 8 wards of the city elected 4 delegates, while 5 delegates were elected at large. How many delegates did the city send to the convention? Now, what is the question asking us to find? Well, that becomes clear. I can often say, well, gee, that's easy. That's the sentence with the question mark. Not everyone is that way, but this one is. How many delegates did the city send to the convention? That's what they want me to find. Step number 2, select the necessary information. So I see a whole bunch of numbers up there, but I worked on this question earlier this week with someone, and the two of us discovered this is a great example of a problem where there's a bunch of special language, special words going on here that aren't everyday words. And if I do not know the clear meanings of those words, I will be stuck. It will be impossible for me to solve this problem. So let's figure out some of this fancy language that's showing up in this problem. They're talking about wards here. Wards. What I did with the person I was working with earlier this week is we hopped onto a Google word search and we just searched up the word wards. And we found out that the word wards means the same thing as a neighborhood. So I could read this problem now and say, for some convention that's happening, each of the 8 neighborhoods of the city, wards are the same thing as neighborhoods for our purposes here. So we know that each of the 8 wards of the city elected 4 delegates. Delegates. Well, what are delegates? That was another word we looked up. Well, delegates are people who are elected by a group of people to do some work for them, to do a project. So these delegates are elected people. So now I can read this and say, well, for the convention, each. That means for every single one. There's another. That is an everyday word, but really got to know that that means every single one. So every single one of the 8 neighborhoods of the city elected 4 elected people. Okay. While 5 delegates were elected at large. And this now, really got to know what that means, because this is totally going to affect the problem. At large means that if, let's say, I've got a city with 8 neighborhoods in it, the first number of people that are being elected from each of the 8 wards. At large means that these 5 delegates are not coming from the wards, they're coming from the city at large. So we've got 4 delegates coming from each of the 8 wards, and another 5 delegates elected to represent the whole city. That's a lot of work, just understanding the problem. We haven't even done any math, so to speak, yet. This has been careful reading, figuring out the meanings of words, recognizing stuff that's fuzzy and making sure it's not fuzzy anymore. So I shouldn't have to guess at what something means. I should be able to look things up and get it as clear as possible. So let's then follow our 2-sentence strategy. The 2-sentence strategy always starts with, what is the solution sentence? Whoops, let me first highlight the necessary information. 8 wards. we've got 4 delegates coming from each single one of the 8 wards, and then we've got 5 delegates that were elected at large. Wow. So you see again that the numbers are helpful, but the numbers alone only tell, or they don't give me the whole story. I need to know the whole story. The 5 delegates are at large. The 4 delegates are coming from each of the 8 wards. All right, solution sentence. Again, remember, this is like working backwards. I'm saying, okay, so what is the solution that I'm after? And the solution always comes from step 1. What is the question asked me to find? Well, the solution that they want me to find is how many delegates did the city send? So I'm going to say the number of delegates that the city sent is going to be equal to, and now I know I've got 2 different kinds of delegates. I've got delegates that are coming from the 8 wards. So we're going to have a bunch of delegates getting elected from the wards, plus I'm going to have the delegates that are those at-large delegates. The at-large delegates. Okay, there's my solution sentence. So when I look at the solution sentence, this again is going to end up being my solution. That's what they're asking me to find. So that's what I want to find. To find that, I want to put together, add together, how many delegates from the 8 wards plus the number of delegates at large. This I know. It's right here, 5 delegates at large. So I'm just going to write that here. I've got 5 delegates at large, but this other delegates from the 8 wards, that's what I don't know yet. I can know it, but I don't know it yet because, and the reason I'm saying I don't know it yet is because that number was not given to me. I have to find it. I have to figure it out. So this is my piece of missing information. So I'm going to turn that into my missing info sentence. And I want to find the number of delegates, that's what I'm missing, delegates from the 8 wards. Well, that's going to be equal to, let's see, I get delegates per ward, the number of delegates per ward times the number of wards. I'm using words here. Now we're going to go on to sentences. The number of delegates per ward, well, that's 4. I see that up here. 4 delegates from each of the 8 wards. And as I said, 8 wards. So that means I've got 32 delegates coming from the wards. Oh, so that missing piece of information that I was looking for up here in the solution sentence, now I have it. I have it from my missing information sentence, helped me to find it. 32 delegates. So I'm going to take that piece of information, bring it back up to where it was missing, and put it in. Now I know it. The number of delegates the city sent, the number of delegates the city sent, that's the solution I wanted to find, is equal to delegates from the 8 wards. Well, that was missing, but I have it now. It's 35 plus delegates at large. And I can say that my solution now is going to be 40, wow, dollars. Why did I put a dollar sign there? Maybe you caught that. That's 35 people. 35 people. So, no, it's not 35 people. Maybe you caught that too. That's 32 people. Wow. This is how easy it is to make a mistake. 32 people. 32 people from delegates from the wards plus 5 delegates at large gives me a total answer of 37 delegates altogether. There's my answer. Make sure that the answer is sensible. Yeah, 8 wards, 4 delegates each, 5 delegates at large. That's a reasonable number. We have a solution. Okay. This is a 2-step problem. If you've read the Unit 10 carefully, you'll notice that this 2-sentence solution works for many problems, but they said sometimes if there's a problem that involves proportions, now you've done a lot of proportion work already if you've been working through the other units. Unit 8 was all about proportions. You might recognize already that proportion problems already are 2-step things. So proportions, remember, are one ratio is equal to a second ratio. There was a video on how to tell if a problem can be solved using proportions. And in that video we said if it can be solved with proportions, that means we find two situations in the problem. And in situation A, there will be a ratio. And in situation B, there will also be a ratio. And the two ratios will be comparing the same thing. So this is one of those. It says apples were sold at a cost of 58 cents for 2 pounds. How much did Michelle pay for 3 pounds of apples? Let's walk our way through the 5 steps of problem solving. What does the question ask us to find? How much did Michelle pay? How much did she pay for 3 pounds of apples? Now, step 2, select the necessary information. Well, we know we have how much money for 2 pounds. That's coming from one situation. The other thing we know is for 3 pounds, and the thing we don't know is how much. So 3 pieces of information were given to us. 2 of them, these 2 right here, that's a ratio, that's a comparison. 2 pounds of apples compares to 58 cents. In Michelle's situation, I'm going to call that situation number 2, is Michelle's situation. There's 3 pounds of apples, so we're comparing pounds again, and we want to find how much money. So we're comparing money to pounds, even in situation number 2. So this fits the bill for a problem that can be solved by proportions. We've got a situation A, the regular cost for 2 pounds, and we've got a situation B, Michelle's cost for 3 pounds. So let's set up the proportion to solve this problem. The proportion is, remember, this is the bones of a proportion. It's going to have situation A and situation B. Situation A is going to have a ratio with something compared to something, and situation B is going to have that same something as this, different number, same idea, compared to the same thing that was being compared over here in situation A. So to set this up, I'm going to say that situation A, I'm going to put cents on the top, and I'm comparing that to pounds on the bottom. I'm going to use LB, the symbol for pounds. So situation 1, it was 58 cents compares to 2 pounds of apples. Michelle's situation is situation number 2. Michelle's got 3 pounds of apples. We don't know how much she has to pay. So to solve there's my proportion. I have one ratio equal to another ratio. I've been very careful to separate situation A, the normal cost, from situation B, Michelle's situation. I've made sure that my first ratio follows the same order as my second ratio. Cents over pounds for the first ratio, cents over pounds in the second ratio. From the ratio work that you've done back in unit number 8, you know that to solve this problem, you multiply the two numbers on the diagonal. So it's going to be 3 times 58, and I can do that in my head using some mental math. 3 times 5 is 15, that's 150. 3 times, that's 174. That's step 1, not situation 1, step 1. Step 2 of the calculation is taking that 174 answer and dividing it by the number I haven't used yet, which is 2. Now, this is stretching my mental math skills, but 2 goes into 17, 8 times, okay, that's 87. 87 is the answer for that. So I have found my missing piece of information. It looks like the answer is 87. I've done step 4, that's my calculation. Step 5, does the answer make sense? Well, 2 pounds costs 58 cents. 2 pounds cost 58. 3 pounds should cost more, and they did. They didn't cost way more, so that certainly seems reasonable. There's an example of a 2-step problem that had all of the ingredients of a proportion thing. So I use proportions to solve it, but notice it's still a 2-stepper because I still did operation number 1 and operation number 2. Back here, when I solved this, here was operation number 1 in my solution sentence. Here was operation number 2 in my missing information sentence. Back in this question, here was operation number 1 in my solution sentence. Here was operation number 2 in my missing information sentence. So there are some examples of 3 more combination word problems. Could also call them multi-step word problems, but these in particular had 2, so I'm going to call them 2-step word problems. 2 of them we solved using the 2-sentence strategy, starting with the solution sentence, expecting that there will be a missing piece of information that was not directly given to me. Then we went back to the problem and found that there was a way to find that missing information, so I made my second sentence to explain how to do that. Once I knew the missing bit, plopped it into the solution sentence, and I'm done. This was the third question we did, and it had all of the ingredients of a proportion problem, so we solved it using a proportion, but we still noticed we end up using 2 operations, which doesn't surprise us. It's a 2-step problem. All right, hope that's helpful.